Hi guys, welcome all to the Max lecture series. So in this series we are learning how to obtain the resultant answer for various single integral functions. Of course you all understood whatever the content that I have delivered so far. If you really understand, don't forget to click that like button and also share it with all your friends. Now just look into the given question. In the last section, in the last class, I had given on a homework question. I am just giving the answer for that question. The correct answer for this question is option B. How many of you got the answer? Please drop your comments in the comment section. Let us look into the next question. So far we understood the difference between a trigonometric function, polynomial function. We found what is the difference, how to obtain the logarithmic function. By parts we understood, even at the odd functions we understood. Unbounded, bounded, definite integral, indefinite integral, proper integral, improper integral. Wow, we learned a lot only through problems. Like that, there is one more thing to learn. Let us understand. If you observe the given question is said it is 0 to lies in between. See, they have given the limit as 0 to a, certain finite limit. And they also given that the function is root of x upon root of x plus root of a minus x into dx. So how can I solve when I am observing these kind of questions? So what you have to do is, usually what I told you, even in when we are observing the trigonometric functions like sin x, cos x, if it is lies in the same pattern between the denominator and the numerator, most of the time I asked you to check whether that function is even function or not, like that, in order to get this solution. In the same way, when some polynomial equation is given like this, under root or something which will be giving you some meaningful relation between denominator and the numerator, always observe the numerator function and the denominator function. If you are observing the same pattern in both numerator and the denominator also in the given function, at least one part, I am not asking you to check the whole part. If whole part is similar to numerator and denominator, they will get cancelled. So it will not be like that. Certain functions will be given with a bounded limit. They will be giving definite limit only. You can understood that they will be giving you certain definite limit. And if you observe the functions which will be giving you some meaningful exact relation between numerator and denominator, some part of the numerator will get matched up with the denominator, or some part of the denominator will be matched up with the numerator. During that case, what I have to do, sir? For this type of definite integral, we are having one shortcut. What is the shortcut, sir? Let me tell you. Nothing is there. In order to bring the solution for this type of question, what we have to do further is take the same function. Okay, take the same function. Just observe the numerator and the denominator. Let me write one more time, root of x plus root of a minus x into dx. Okay sir, that is the given function. Now give some name for this. Let me call this function is I, and I am giving this equation number 1. After that, what you have to do is take the same function 0 to a. Now add your upper limit plus lower limit. Upper limit value is a, lower limit value is 0. What you have to do is, after adding upper limit with the lower limit, just take the internal variable. What is the internal variable here? Sorry, what is the variable that you are going to integrate for this whole function? X. So after adding upper and lower limit, just subtract that variable from the function. So here I am going to differentiate the function with respect to x. So just find the difference between 0 plus a minus x. Okay sir. So how can I proceed further? After that, what you have to do is, wherever you have x in your function, replace all x by its resultant answer. Are you getting me? What I told you, upper limit plus lower limit you have to add, and then you have to subtract with respect to the function that you are going to, with respect to the variable that you are going to integrate. I am going to integrate this whole function with respect to x, so I have to put x here. Now you can substitute wherever you have x in your whole limit, in your whole function, replace all x by this resultant answer. Then what you will be getting? Upper limit. See, upper x will be replaced by a minus x. Now go to the denominator, replace x by a minus x, plus again go to the denominator, a minus x will be replaced by a minus x with respect to dx. Now what is the conclusion? If you reduce this expression, you will be getting 0 to a. Numerator we will be observing a minus x upon, in the denominator we will be observing a minus x plus, if you open up the bracket, that will give you a minus a plus x. A will get cancelled out with respect to dx. So finally what we will be observing here is integration 0 to a square root of a minus x upon square root of a minus x plus square root of x with respect to dx. Treat this one as your equation number 2. Okay. Now after that what we need to do is add equation number 1 with the equation number 2, both LHS and RHS. See there, I told you both are equal. If I will add these two equations, not both are equal, we can directly add these two functions, right? If I will add I plus I will give you 2i. Okay sir. In the LHS if you add, so if you add the RHS this one and with this one, if you add both, then this will give you 0 to a. First we are having square root of x upon square root of x plus square root of a minus x into dx. In the second case our limit observation will be giving us 0 to a square root of a minus x upon square root of a minus x plus square root of x into dx. Now see there, you can also combine this limit, this whole limit now. Since both are having same limits, so you can group them together, resultant 0 to a. If I will add them together, it will become x plus square root of a minus x. Denominator is common for both, it will become square root of x plus square root of a minus x into dx. Wow, what we got here, sir? The numerator and the denominator getting cancelled, sir. So the resultant answer 0 to a simply 1 into dx. This will give you integration of 1 with respect to dx will give you x. Limits are going to be 0 to a. So upper limit is a minus lower limit is 0. Of course this will be equal to a only. But if you observe in the LHS we have 2 times of I. We need only I. Because what is the question? I is dash. I equal to this overall function, resultant answer is dash. I am treating this overall function equal to I simply. So the resultant conclusion is I is equal to a by 2 is the correct answer for this function. So let me tell you, don't worry, there is a property for this definite integral. Anyway, correct answer is option B. Sir, how did you got this idea? So whenever we are observing definite integral, I also told you to observe the numerator and the denominator. If you find the similarity at any one portion, directly you can observe this property. So this is the one of the property of definite integral. The actual relation is, suppose a limit is defined as a to b and a given function is f of x into dx. This will be equal to, both will give you the same result. A to b you can write f of, add upper limit plus lower limit minus subtract with the variable that is already given. That is with the variable means the variable that we are going to integrate the whole function with respect to into dx. This both will give you the same result only. These both are equal actually. So the conclusion is, I had given this whole function we are treating it as I. This whole function we are treating it as I. We are adding this resultant two functions equal to some integration. When we are adding, automatically entire things will get cancelled out. You will be getting some finite value here. So finally your answer is going to be finite value divided by 2. That's all. This is standard whenever you are solving this type of question. So don't forget what you have to do, just to check the similarity between numerator and denominator and then identify whether the given limit is having a finite, like a finite limit between some point to some point, because it should be definite integral. You know the meaning of definite integral, I have been told you already. So definite integral, yes sir, it is definite integral, and I am finding the similarity between some part of the numerator and the denominator, or some part of the denominator with the numerator. After that you can apply this property, automatically you will be getting the resultant answer. Okay, this is all for this lecture. Remaining things we will see in the next class. Thank you all.